Welcome to the Anthropocene. We now live in an age where we're, as humans, are not only just reacting to the climate and regions that we live in, we're actually causing changes to the global makeup and the climate. The Anthropocene is relating to or denoting the current geological age. This is viewed as a period during which human activity has been the dominant influence on changes in climate and the environment. To say that the Anthropocene is a geological age is really a very big deal. If you think of other ages, other geological ages in the Earth's history, it's comparable to things like the prehistoric age, which was defined by the dinosaurs and their impact on the globe, or the Ice Age, which was defined by a climate condition where there was ice, surrounding the globe. The Anthropocene is just as significant, and the impact that humans are having on the environment creates just as much of an impact to be called an age. So what are some causes of the Anthropocene? What from human activity is causing such a dramatic shift in the climate? Greenhouse gases are perhaps one of the biggest culprits. These are particles that accumulate in our atmosphere. Now, some greenhouse gases are natural because we want a certain amount of warmth on our planet. So things like water vapor and ozone. But then we have a buildup of unnatural carbon dioxide, or known as CO2, along with methane, nitrous oxide, and others. These absorb radiation and emit thermal radiation. And a huge source of greenhouse gases comes from burning and combusting hydrocarbons. Now, hydrocarbons are Earth's most important resource as to date, and these are a combustible fuel source. So when we dig up petroleum and oil, which essentially are the bones and decaying matter of dinosaurs and plants that existed thousands of years ago, we are bringing up these long carbon chains. So hydrocarbons, they think of it almost as a huge chain link. Now, we use fossil fuels such as coal, petroleum, and natural gas and other derivatives to create plastics, fuel, paraffin, waxes, solvents, and all kinds of things. However, by burning these things, it creates the formation of tropospheric ozone and greenhouse gases, and these build up in our atmosphere. So every time fossil fuels are burned, CO2 particles are emitted into the atmosphere. This causes a build-up of greenhouse gases and what's known as the greenhouse effect. So think about it, if you are in a greenhouse in a home. There may be glass and plants in an area near a house, and you're able to let the sun in, and it can get really hot in there because the solar radiation is not able to escape. Well, the same thing happens with the Earth. These greenhouse gases will absorb some sun radiation and then allow a certain amount to pass, but then the solar energy cannot, it keeps it from being released. And this, in a sense, starts to cook our planet. This creates what we call climate change. But before we talk about climate change, let's go a little bit more into the greenhouse effect. So again, looking at our example, by burning fossil fuels, Also cutting down forests that are able to clean the air by emitting harmful CFCs, not just in aerosols, but mainly in refrigerants. The combustion of fuel using from cars and from industry, all of those things are emitting greenhouse gases. So those build up in our atmosphere, you can see in the example, and the amount of radiation that's able to come and hit the Earth's atmosphere, without being able to escape, it just bounces back into the Earth and creates what's called the greenhouse effect, what we were talking about earlier about this cooking of our planet. And the overall cooking of our planet causes dramatic shifts in natural cycles. This is due to melting of the ice caps, which holds a lot of fresh water on the planet. And so when those start melting, sea levels everywhere start to rise, currents start to change, and we start seeing more violent storms. We start seeing changes in the balance of our cycle. So remember, from our previous lecture, we talked about ecosystems, we talked about ecology, we talked about the biosphere, and all these things being how different factors are interrelated. So while something like a 2-degree change in the overall Earth's average temperature may not seem like a whole lot, 2 degrees change can wreak and havoc on the balances that nature has taken thousands of years to have. It's important to note that climate change and weather are not exactly the same thing. So, for example, in the United States, in the South, in Texas, and in Florida, and those regions, there are regular hurricane seasons that tend to happen. This is part of an overall weather pattern, and it's happened for quite a while. But however, due to climate change, the average temperatures in the ocean end up becoming a little bit higher. There's more moisture in the air. Sea levels have risen. It makes storms a lot more volatile, like what we've seen with Sandy, Katrina, Harvey, Irma, and many, many more to follow. And climate change does not just have to do with rising sea levels. It also will feed imbalances in other regions. So while you may have hurricanes and floods in one region of the country, there are droughts which are causing fire-prone areas in others, because the entire balance of the ecosystem tends to become off kilter. There also was a change in terminology. I'd say about 15 years ago, people used to talk of global warming, and that was a little bit of a misnomer, because while there are areas that start to get hotter, it also causes temperature imbalances. So areas may also start to get colder while other areas are getting warmer. So climate change is actually a more accurate term than just global warming, even though it is happening because of an overall warming of the planet. Another adverse effect of an increase of chemicals and greenhouse gases in our atmosphere is acid rain or acid deposition. And this is air pollution. And it gathers into the water vapor and rains down on the earth. That gets absorbed by plants, starts eroding at metal and stone and concretes and paints. It also can get absorbed in our own skin. So again, as we talked about in Module 1, the environment really does not have strict boundaries. So things pollution that is put out there will run through the entire ecosystem. So let's talk about the types and sources of pollution. Primarily, they can be categorized into two categories: non-point source pollution and point source solution. So again, non-point source solution and point source pollution. So non-point source pollution is when you have pollution coming from a variety of sources. So, for example, water pollution in a pond could be the result of toxins from a nearby landfill, pesticides used on a farmland, and poisons in the residue of rainwater. It could also be contaminated stormwater, washing off a parking lot, roads, highways, and all of these different things going into, let's say, a water body to pollute it, which means there's a variety of sources. There's no real one culprit you can point to. This is called non-point source pollution. However, then we have point source solution, and this is when you have a very direct cause and effect when it comes to where the source of a pollution is. So for example, if we have water pollution from an oil refinery, that is directly dumping into a wastewater discharge outlet, we know that oil refinery is the cause of this particular pollution. Or noise pollution coming from a jet engine or from a submarine, or light pollution from street lights, or thermal pollution from some industrial process. But when we know what the source is and there is a single source for it, we call it point source pollution. And a common result of all of this pollution in the air can be known as smog, industrial smog or photochemical smog. And smog is not only these greenhouse gases hanging out in the atmosphere, but this is actually when they start creeping down into ground level air breathing zones for airs. And it tends to be a huge problem in a lot of major cities such as LA, Toronto, New York, Beijing, Bombay, Delhi, with the worst result being the effect on human health. This can cause asthma, bronchitis, all kinds of other respiratory diseases. And smog is measured in parts per million. So meaning how many particles in the air are there in a given sample. And smog becomes especially worse in summertime when the air is hotter. These particles tend to get more excited with the added heat of the season. Now, in many cities, such as Beijing, for example, the level of smog in parts per million can be up to 30 times the amount that is even the max limit suggested by the World Health Organizations. And in many cities, we're seeing a new norm of people wearing face masks to be able to shield out air pollution. If this is the new norm, then we're obviously heading in the wrong direction. Is this really where progress should be taking us? Is this how we are intended to live?